Okay, y'all ready? Here are some homework questions over 2.6. Let's review. On 15, you're asked to find the domain. So when you look at this, you hopefully say, wow, that is a complex fraction. It's a fraction within a fraction. And so the first thing you look at is this right here, and you go, well, there's a problem there. What can x not be? 1. Because if x is 1, then 4 over 1 minus 1, 4 over 0, this piece is undefined, and if this piece is undefined, the whole fraction is undefined. So that's one restriction.
And
X
3
cannot be 1. And the other one, you're right, the other one comes from this fact. You've got to consider that some number might make the whole denominator equal 0, so you're going to ask yourself this question: when is 4 over x minus 1 minus 2 going to turn into 0? Solve that, add 2 to both sides. So 4 over x minus 1 equals 2. And then, if we multiply both sides by x minus 1 to clear fractions, because we don't want x in the bottom of the fraction, then we have just 4 equals, distribute, 2x minus 2. We add 2 to both sides, 6 equals 2x. Divide both sides by 2, x equals 3. So now let's play with this. What if we plug 3 in here? 4 over 3 minus 1, that makes 4 divided by 2, which is 2. And 2 minus 2 equals 0. And so 3 is a problem. X cannot equal 3. If I ask you to talk to me about the domain in interval notation, you're going to describe where all on the x-axis can we find things that are okay to put in. Well, anything except 1 and 3 are okay. Any numbers except those two are okay. So where can you be on the x-axis? You can be from negative infinity up to 1. Don't include 1. Then you have another piece that where you can be, or you can find x values on the interval from 1 to 3. And you can also find x values on the interval from 3 to infinity. Any numbers in these intervals are part of the domain. They're okay to input. On number 40, there were really 4 problems on this one. You were asked to perform operations. Do f plus g, f minus g, f times g, f divided by g, and then talk about the domain for each one of those. So on number 40, if you do f of x plus g of x, that means you're going to add square root of x plus x minus 5, and there's not a whole lot you can do with this. That's it. So f of x plus g of x, though there are no likes terms, there's nothing else we can do with it. But if you talk about the domain, there are some restrictions. You don't want to be taking the square root of a negative number. So that means x has to be positive. And to talk about x being positive, it has to start at 0 and go toward infinity. Okay? On the next one, if you do f of x minus g of x, here is where you have to be careful, because you got to do the square root of x minus all of x minus 5. And when you want to be sure you're subtracting all of function g, you got to have parentheses, and then you'll have a negative in front of the parentheses, so that makes it square root of x minus x plus 5. There's nothing else we can do with that. But we can talk about the domain. The domain, again, we don't want to take the square root of a negative number. So from 0 to infinity. If I ask you to do f times g of x, when you multiply those two functions, square root of x times all of x minus 5, you can distribute, but you can't. When you multiply negative 5 times square root of x, it's just negative 5 square roots of x. So when you write this one, it's x times square root of x minus 5 times square root of x. That's it. You can't do any better. But you can talk about the domain. And the domain, again, you don't want to take the square root of a negative number. So the domain is still only positive numbers. Start at 0 and go to infinity. When we talk about f divided by g of x, then we're going to do f of x square root of x, divided by g of x minus 5. And again, there's really not anything I can do to simplify this. That's about as good as it gets. But when we distribute, when we consider the domain, we do know that from right here, what's the deal with x? Can't be 5. So x has a restriction, x can't be 5, and what else? No negative numbers. If I draw you a picture of the domain, then it's going to start at 0 and only include positive numbers, except there's one positive number that we have to throw out. X can't be 5. So when you describe the domain using interval notation, you will have to do it in pieces. You will have to say the domain goes from 0 up to 5, not including 5. We got to hop over 5, and then join it with a piece on the other side of 5 from 5 to infinity. Does that make sense?
Why is it starting at 0?
Because if you take the square root of, if you put negative 1 in there, the square root of negative 1 is I, imaginary.
So if you have the square root in the problem at all,
Then you don't want to have the square root of a negative number.
it'll always start at 0.
Not necessarily. If I gave you this, the square root of x plus 2,
Oh, then it was.
then
in 2.
and start where? Or do you say 2? What would have to happen is that x plus 2 needs to be bigger than 0. So if you solve for x and you subtract 2 from both sides, x needs to be bigger than negative 2. If you plug in negative 2, or equal to, if you plug in negative 2 plus 2 gives you 0. If you plug in something smaller than negative 2, like negative 5 or negative 6, negative 6 plus 2 is negative 4. Now the square root of negative 4, it's imaginary, 2i.
So you can still do it even if it was like x minus 5.
Yeah, if you have this, the square root of x minus 5, then what do you need? What do you know? Whatever's underneath the radical has to stay positive. So x minus 5 needs to be bigger than or equal to 0. So in this case, x has to be bigger than 5. If you plug in 5, 5 minus 5 gives you 0, square root of 0 is 0. If you plug in 4, what happens? 4 minus 5 is negative 1, and the square root of negative 1 is imaginary. So whatever's under the radical needs to stay positive.
So it's just if it was just x by itself.
Then it's bigger than 0.
Gotcha.
Okay, 65, look at that one on your 2.6 homework. And which one did we just do?
45 or 40.
And 45 is similar. It has more to do with radicals. So I think you can now do 45. Let's talk about 65. 65, I think, asks you to compose two functions. On 65, f of x is 2 over x plus 3. And g of x is 1 over x. And you were asked to find two things, f circle g of x, and then talk about the domain after you compose them. Well, f circle g of x means, I don't really like this notation as well as this. It means function f with function g dropped in. So if I drop all of function g into the input, now I'm doing f of 1 over x. Rule F says do 2 divided by whatever your input is plus 3. Sometimes it helps if you will actually write a rule in words. So the rule for function f is do 2 over the input plus 3. So if the input is 1 over x, then that means you will do 2 over 1 over x plus 3. That's a complex fraction. We worked on complex fractions a lot earlier in the year. So 2 divided by 1 over x plus 3, when we worked on complex fractions, we said, do all you can do on the top, then do all you can do on the bottom, and then work from there. There's nothing I can do with the 2. But on the bottom, if I want to add these two fractions, what do I need?
Common denominator.
And a good one would be
X.
x. So I'm gonna call this 1 over x plus, instead of 1 times x gets me to x, 3x.
Well, it's be negative.
Go ahead, say
Or-
again.
Maybe the x would be negative 1/3. Yes.
Okay, for the domain.
Yeah, I think so.
Okay,
Or it can't be that.
hold that thought. If I combine these two fractions, now I have 1 plus 3x all over the same denominator, because remember, that's what we did. Once we get a common denominator, we combine the two fractions into one. And then remember that this bar really means divided by. So I have 2 divided by 1 plus 3x over x. How do you divide by a fraction?
Flip the, I mean, you just switch the sign and multiply. You know, something.
So it makes it 2 multiplied by, flip the second one, the reciprocal, 1 plus 3x. Where do we land? 2x over 1 plus 3x. What is this? This is what you get when you do function f with function g dropped in as the input. Alright, now, so there's part A. Part B says, what's the domain? Are there any restrictions we have to worry about?
Negative 1/3.
Yeah, because the question we gotta ask is, what's gonna make 1 plus 3x turn into 0? If I subtract 1, then 3x equals negative 1. X equals negative 1/3. If we plug negative 1/3 in for x, then it'll make the denominator turn into 0. So x cannot be negative 1/3. If I ask you to write it with interval notation, you need to draw a picture. The entire x-axis is okay, except at negative 1/3. So in interval notation, you would tell me from negative infinity to negative 1/3, hop over it, don't include negative 1/3, but join it with the piece from negative 1/3 to infinity. Can you hit stop on that?